Imagine your friendly AI coding assistant suddenly turning into an insider threat. It might sound far-fetched, but research has revealed exactly that scenario. A widespread systemic security issue aptly named IDEsaster. This isn't just one bug in one product, it's a whole new class of vulnerabilities affecting nearly all AI-assisted development environments. As a techno-legal analyst, I'm here to guide you through a deep dive into this issue. We'll unpack how autonomous AI agents in our IDEs, integrated development environments, they have opened up a universal attack surface and what that means for developers, tool vendors, policymakers, legal professionals, and security stakeholders. This is expert analysis of the findings, not merely a summary, so expect insights into privacy, liability, and systemic risk at every step. IDEsaster was discovered by a security researcher, Ari Marzok, who found that integrating AI into coding tools can weaponize these tools against us. We'll explore concrete case studies of how an attacker can steal data or even execute malicious code through your AI-enhanced IDE. More importantly, we'll examine the broader implications, how this new threat it forces us to rethink security design, secure for AI, and consider new legal responsibilities. So buckle up for a technical deep dive with a legal lens. By the end of this, you'll see why the integration of autonomous AI has fundamentally changed software security and what we must do about it. 100% of tested AI IDEs are vulnerable. That's not a headline from a tabloid. It's the sobering finding of this research in Macarita.com. Every single AI-enabled coding tool examined had security flaws. Over 30 separate vulnerabilities were identified across more than 10 major products, with 24 CVEs assigned so far. So in other words, no one is safe by default. You see some of these key statistics. 100% hit rate on vulnerabilities, 30 plus flaws discovered, affecting millions of users. These aren't obscure tools either. We're talking about popular AI coding assistants like GitHub Copilot, Cursor, Amazon's Code Whisperer, JetBrains, Junie, and many more. If you use an AI pair programmer or an IDE with AI features, chances are it was found to be exploitable under this new IDEsaster class. So why do these numbers matter? They tell us this is a systemic problem, not a one-off glitch. It's like learning that every car model from a certain year has faulty brakes. The entire class of product is affected. For security stakeholders, this is a red alert. Our attack surface in development tools has expanded dramatically. And for legal and policy folks like us, it raises accountability questions. If millions of developers are put at risk by these vulnerabilities, who is responsible? Is it the vendors? Or is it the open source maintainers of the IDEs? How should this widespread risk be disclosed and managed? We've already seen an AWS security advisor acknowledging the threat in the publication, and documentation updates warning users, for example by Anthropic's Claude Code. These are early signs of industry response, but the sheer scale indicates we might need more, perhaps coordinated industry standards or regulatory guidance to ensure such tools are safe. The key message of this video is that the ground has shifted under us. Why are all these tools vulnerable? Because we have essentially bolted a jet engine onto a bicycle. Our traditional code editors, IDEs, were never designed with autonomous AI in mind, yet we've added AI agents to them as breakneck speed. This part of the video contrasts the legacy IDE architecture with the AI agent reality. On the left, you can imagine a classic IDE. Features assume a human developer is firmly in control. Every action is initiated and vetted by the user. And on the right, we have today's AI augmented IDE. An autonomous agent can generate code, modify files, and execute tasks on behalf of the user, sometimes without explicit approval. So now the problem. IDEs were not initially built with AI agents in mind. By plugging AI into these environments, we inadvertently created new attack vectors, changed the attack surface, and reshaped the threat model. Features that were harmless or low risk in the hands of a careful human can become dangerous when an AI is driving. For example, a feature that automatically formats code or fetches resources from the web. Benign when you trigger it might be co-opted by an AI that doesn't understand context or trust. The result is new predictable risks, as the researcher puts it. Think of an IDE feature like a powerful API. In the old model, the API is only called where the human developer decides to. In the new model, the AI might call that API in response to some prompt or hidden instruction. Legacy falls short. The AI might not have the same judgment or context a human would. And the IDE isn't asking, "Are you sure?" because it never needed to before. From a legal perspective, this mismatch raises the issue of foreseeability. Should vendors have foreseen that adding autonomous AI would introduce these risks? If an AI in an IDE inadvertently causes a breach, say it leaks sensitive data or executes malicious code, one might argue the vendor failed to exercise due care by not adapting the product's security for AI use. This is where the concept of secure for AI coming up next is crucial. But on this slide, the takeaway is we have a design gap. The AI agent reality has outpaced the safety assumptions of legacy IDE architecture. The cost of that gap is what we are now uncovering as IDEsaster. So by now you would be thinking, how do we prevent the next IDEsaster? By changing how we build software from the ground up. If the last slide showed that traditional secure by design practices fell short, this one introduces a solution. Extend those practices explicitly to account for AI. Secure for AI is a term coined in this research. It means that when designing systems, engineers must deliberately consider how AI components could be misused or go rogue. It's an evolution of the familiar secure by design and secure by default principles. In plain language, design your software as if an AI, which could potentially be subverted by an attacker, will be using it. On the slide, you might see a diagram or bullet points explaining this. Think of it like this. Secure by design, classic concept. It says you build software from the start with security in mind, minimizing vulnerabilities. Secure by default says the default settings of software should be secure, not leaving dangerous options open. And secure for AI adds account for AI-driven functionality specifically. Assume that any AI you integrate could be tricked or could be manipulated, and still your system should remain secure. In practice, secure for AI could mean adding checks and balances where none existed before. For example, if an AI agent can edit files, maybe the system should restrict what files or require confirmation for sensitive ones. If an AI can execute code, sandbox that execution. If an AI can make network requests, perhaps limit where it can call. So basically, identify every way an AI feature interfaces with your system, and then you ask, what if the AI was under an attacker's control? Then build in mitigation so even in that worst case, your product is safe. From a policy perspective, this principle might soon move from academic to expected. Just as regulators now talk about privacy by design, especially after laws like GDPR, we might soon hear about security by design for AI. It's a proactive stance. If companies adopt secure for AI internally, great. If not, we could envision industry standards or guidelines pushing them to do so. For example, a government or industry body could issue best practices for any developer tool that includes AI, effectively mandating something like secure for AI. The aim is to avoid the situation we are in now, where AI features were bolted on without full security re-evaluation. In summary, this slide sets a hopeful tone. We have a strategy to deal with these new AI risks, but it requires forward-thinking design and possibly a nudge from policy to become the norm.